So we now want to look at torque as an application of the cross product. And if we look at this diagram here, we have a bolt with a type of wrench. R is the length of the wrench or the lever arm. And you're most likely familiar with trying to either tighten or loosen a bolt. The force is typically applied here at the end. So that's why the force arrow is there. And torque is a force it's a rotational force that helps to either loosen or tighten things like bolts. So notice that in this diagram, to help us make sense of why the cross product is useful here, we've moved this force vector here, and we've put it at the location of the center of rotation, so the bolt. So while technically the force is applied here at the end of the wrench or the lever arm, to make sense of a cross product, we're going to consider it being located here at the center of the rotation. So with that in mind, thinking about that right-hand rule for cross products, if I have a right-hand threaded bolt, then this radius, this R, cross F, line your fingers up with R, curl them towards F. Your thumb will be pointing upward, and you will have basically what we see here as the torque, or the rotational force, necessary to either tighten or loosen the bolt, depending on the direction of the force. So now I'm going to apply the same reasoning here on this bolt and wrench that we have. We've got a situation where a bolt is being tightened by applying a force of 6 newtons to a 0.15 meter wrench. The angle between the wrench and the force is 40 degrees. Find the magnitude of the torque about the center of the bolt. So the force is being applied here at the end of the wrench. So I'm going to apply the same reasoning as we saw in the general model, and we can think about the force being applied like so, and the angle between the two would still be 40 degrees. Okay, so let's go ahead and solve this. So torque is a vector. Because this is a cross product, we use the Greek letter tau, and torque is that radius arm crossed with our force. Now, in this particular case, we're just asked about the magnitude. So we're looking for the magnitude of the torque, which is going to be the magnitude of R cross F, which is in fact equal to the magnitude of R, the magnitude of F, and in our case, the torque will be magnitude of R. That's how long my wrench is, and it's 0.15 meters. The magnitude of the force, looking at our diagram, we see that that is 6 newtons. And then sine of 30 degrees. Oh, my bad, 40 degrees. Well, if we go ahead and multiply that out with the sine of 40 degrees, we'll find out that the torque here is approximately 0.58 Newton meters. That is the magnitude of the torque on the bolt in this example.